Hello pre-calc. Here's the video for 5.5, inverse trig functions and solving right triangle problems. So first thing I want to discuss is the difference between a reciprocal function versus an inverse function. A reciprocal function is like if I gave you cosecant theta, the reciprocal would be 1 over sine theta. Now, unfortunately, on your calculator, what we have is a button that looks like that. That would also represent 1 over sine theta, which is cosecant theta. But again, that's a reciprocal function. A reciprocal function is you have a function and you can take its reciprocal, throw it underneath 1, or vice versa. All right? Inverse function has one particular task. The task of an inverse function is to solve for an unknown angle. And it is going to look like, so we know that, let's say, the sine of theta is the opposite over the hypotenuse. Well, let's say I happen to know the opposite over the hypotenuse, and what I want to find is theta. So we take the inverse sine of both sides, and you end up with something that looks like this. All right, so if you look at your calculator and you see your sine, cosine, tan, right behind it, you'd have to use your second feature to get it, you'll see the inverse trig. Now, if you have the TI Inspire, you're actually lucky because your trig key will have all 6, sine, cosine, tan, cosecant, secant, cotangent, and their inverse, which is kind of nice. So I want you to realize that this -1 is different than the reciprocal -1, which means take the reciprocal. This one actually means you are solving for the angle, and your goal is to solve for an unknown angle. All right? Okay, so let's look at how we're going to do this. First thing is make sure that your calculator is in degree mode for right now. So if you have a scientific, you should have a little DRG RAD button. So you might see DRG RAD for radians. You want to make sure you're in degree mode. If you have a grapher, hit the mode key and see where it says degree and radian. It'll say radian, then degree. It's like the third line down. Highlight degree, hit enter. You should be good. It won't change unless you change it. So what we're going to do is we are going to find theta. So cosine theta equals 0.8, sorry. So this is really what we're doing. We tend not to write it all out, but I'm going to, on this first one, just show you how it works. Cosine theta equals 0.8. What we're going to do is take the inverse cosine of both sides. So the inverse and cosine are reciprocal functions, kind of like x squared and the square root of x. These cancel each other out, leaving me with just theta equals the inverse cosine of 0.8. And now in degree mode, I can go to my calculator, and you're going to go second cosine and then enter in 0.8. So I go second cosine 0.8. And I get, and again, we round to the nearest degree when it's an angle. So I'm going to round that to 37 degrees. All right, so hopefully that's what you got. If you didn't get that, it might mean you're not actually in degree mode. Now, what if you have cotangent theta and you don't have a TI Inspire? So we do need to know how to enter this. So I would do inverse cotangent of 2. I'm isolating my theta, but we don't have a cotangent key on the TI-84. So remember, what is it that is reciprocal? When you have a triangle, So here's my theta, here's the opposite, the hypotenuse, the adjacent. We know that cotangent is the adjacent over the opposite, whereas tangent is opposite over adjacent. So what I can do, since I don't have a cotangent button, the part of this that is the reciprocal, I'm going to undo that, is the tangent. So I'm going to do an inverse tangent of the reciprocal ratio, because that's going to be the opposite over the adjacent. Notice that the cotangent of 2 would go with the same angle. But now I can enter it. So second tan, and we're doing 1/2 or 0.5, and that is going to approximately give me 27 degrees. All right, let's try that again. Oh, this one is just a sine. Okay, so we have theta equals inverse sine 1.5. So when you go and do that second sine 1.5, hopefully your calculator gave you some sort of an error, because think about what this means. Inverse sine, so sine is usually, here's your theta, opposite over hypotenuse. Remember, the hypotenuse is the longest side of a triangle. So 1.5 is equivalent to 3/2. That means you're saying the opposite is bigger than the hypotenuse, which is not possible. And when we start graphing, well, and you guys have already done a little bit of graphing. Remember that sine and cosine fall between 1 and -1, and the reason is because the hypotenuse has to be the longest side, and it goes in the denominator, which means your ratio will always be less than 1 or -1, or equal to. Okay, so that's how you'd use your calculator just to find the unknown angle. Now we want to solve some right triangle problems, which you guys did this in geometry and you did it in A2A, so this should be kind of friendly. But a reminder, what should you do, sort of the process? First thing is always draw and label a diagram. That also helps those of us who are looking at your work to see whether you really understood the setup for the problem. So we draw and label a diagram. Then we set up the relationship. You know, the sine of the angle is the opposite over the hypotenuse, filling in whatever the given information is, and then solve for the unknown. So the unknown might be a side or it might be an angle. Let's do a problem, see how this would work out. Okay, you are standing 75 feet from the base of a building, and the angle of elevation to see me at the top of the building is 47 degrees. All right, so we know there's a building involved. And just a little bit of a reminder, if here I am standing at the top, if I am looking down, so again, straight out, that's my horizon. So if I'm looking down at something on the ground, see, I'm going to be looking at my puppy. Here's my puppy. It's like, wait, why are you way down there? That angle that my eyes go through from looking straight ahead at the horizon to looking down at my dog, that is called the angle of depression, because your eyes are looking downwards. My dog, meanwhile, is looking up at me. And so the angle, so looking straight ahead, that's his horizon. Looking up at me, that is called the angle of elevation, because his eyes are going up. And if you remember from geometry, these are alternate interior angles, so they're also congruent. But remember, the angle of depression quite often is not a part of the triangle. Sometimes, depends, but most times it's not. So you want to use that angle of elevation, which is an equivalent angle, but is inside the triangle. All right, so our little situation, we have you are now being played by my dog, sorry, are 75 feet away from the base of the building, and the angle of elevation to see me is 47 degrees, so that's going to be 47 degrees. So that would be our setup. Then they want to know if you walk 25 feet closer to the base of the building, what will your new angle of elevation be? I'm going to, just because that picture is getting a little busy. So if you walk 25 feet closer, that means you're now only going to be 50 feet away. And we want to find what this new angle of elevation will be. So we are going to have to do a little bit of work on the other problem so we can translate it. So on this first problem, I was 75 feet away. My angle of elevation was 47 degrees. That would allow me to find the height of the building, which is a constant. That height of that building is not going to change. All right. So that would be setting up the situation. Now to set up the relationship, notice that this is the opposite and this is the adjacent. And what goes with opposite and adjacent is tangent. So I'd write out the tangent of an angle is the opposite, which in this case is the height of the building, over the adjacent, which is the 75 feet. So I can actually then cross multiply and solve for the height of my building. So again, I'm still in degree mode. Clear out my error. So I have 75 tangent 47 is going to give me about 80.428. I don't know. We'll just round it to there. Is this, what are we talking? Feet? Feet. Okay, so that's approximately the height of the building. What that means is I can use that height over here. So 80.428 feet. Hello? Okay, sorry about that. A little phone call in the middle. All right, so we know the height. Now our goal is to find for this unknown angle of elevation. So I have the 50 feet because I've moved 25 feet closer. I know the height of the building. So the relationship is still opposite over adjacent. So the tangent of my unknown angle is 80.428 over 50. So let's go ahead and make a decimal out of that. So that divided by 50, 1.609. So tangent of theta equals 1.609. And again, we want to solve for theta. So we take the inverse tan of both sides. Now with tangent, because it has nothing to do with your hypotenuse, you can have a value over 1 because it's just the opposite and the adjacent, that ratio. So if I go second tan 1.609, I get that theta, and again, we're going to round to the nearest angle, is approximately 58 degrees. So now, if that is my angle of elevation, that will also be the angle of depression from the top. All right, so both of those are going to be 58 degrees. And what is the height of the building? We had to find that to solve the other problem. So it's approximately that many feet. All right, so draw those diagrams, set up that relationship, solve for the unknown.